Hello, everyone. It's indeed inspiring to see you back again. And we are discussing understanding and planning of Hadoop clusters. This is tutorial 4 under Big Data series. Let's begin now. First of all, today we will be discussing about different Hadoop releases. You can see here I have a list of Hadoop 1.x, Hadoop 2.x, and Hadoop 3.x. Let me take you to these different releases under hadoop.apache.org, and this is the page. So you can see that this is the initial releases, the earliest releases. Okay, and if you can click over here next, it will take you to the sooner releases. Okay, the latest release you can see at the first page, and this is the latest release, release 3.3.1. Okay, this is the release which is the latest one. Now let me take you to the main website, that is hadoop.apache.org. You can visit this website and you can always keep a track of what is being developed under Hadoop. Let me show you. Here you can see that modules. So we have Hadoop Common, we have Hadoop Distributed File System, we have Hadoop Yarn, Hadoop MapReduce, and Hadoop Ozone. So these are the major modules under Hadoop today. Okay, and the related products here we have are Ambari, Avro, Cassandra, Chukwa, HBase, Hive, Mahout, Pig. So the list is quite big. Okay. Now, the latest release, if you see, the latest release we have is 3.3.1, which was made available on June 15, 2021. And you can see that this is the first stable release under 3.3.x. So after 3.3.0, this is the 3.3.1 first stable release. Okay. Now, let's go back to the presentation and discuss further. We will be starting with Hadoop 1.x architecture. Let me tell you, this is obsolete. Okay, so Hadoop 1.x has been obsolete. This is no more used, but just for the sake of understanding, I'm helping you out. So here you can see Hadoop follows master and slave architecture. So it has got some master components and some slave components. Let's begin with the master components. It has got master component as name node, secondary name node, and job tracker. These are the three master component it has. And slave components, it has data node and task tracker. These are the two slave components. Now they have some functionality. Only two functionalities we will discuss. One is the storage functionality, another is the processing functionality. So the storage functionality, it is handled by name node along with secondary name node, and the slave component we have is a number of data nodes. So name node, secondary name node, and a set of data nodes, they all handle the HDFS, that is Hadoop Distributed File System part. And similarly, if you want to process the data, at that point of time, you have job tracker. And along with job tracker, you have a set of task trackers. Multiple task trackers are there, which help you to execute some application. So Hadoop 1 was only supporting map reduce kind of execution, where we have a map phase, we have a reduce phase. We will discuss about it. Don't worry. Okay. So this is the second part of our cluster. Here you can see we have one more component which is called as client. Client can interact either with name node or with job tracker, because if client has to store some data, load some data, at that point of time, client is going to interact with name node. If the client has some job, some program to be executed, then at that point of time, client is going to interact with job tracker. So this is how the interaction is going to be. Fine. So this is Hadoop once architecture. Just remember the components: name node, secondary name node, along with data nodes, they create the SDFS part. Job tracker, along with the task trackers, they create the map reduce part, processing framework. Okay, let's go ahead and understand more on it. Now we are coming to Hadoop 2.x. So in Hadoop 2.x, there's a major difference, major change which happened. Job tracker and task tracker components were replaced by a new framework which is called as Yarn. Yarn is yet another resource negotiator. Okay, so let me write it for you. Let another resource negotiator. Okay, so this Yarn, yet another resource negotiator, this actually is consisting of a resource manager as well as your node managers. So you have resource manager here, and we have a set of node managers here. Okay, so the slave components here, we have node managers. The master component we have is resource manager. And then here we have node manager, name node and secondary name node. It is like the previous one, name node, secondary name node, and data nodes, they together handle the SDFS part. Okay, so what new comes here is resource manager and node manager. Now let me tell you a few things in brief, which we will discuss in detail when we are comparing all these architectures. That time we will discuss in detail. Now, let me tell you that in Hadoop 1 architecture, the major drawback was in Hadoop 1's architecture that we have a single name node. And if this name node fails, what will happen? Nothing will work out, right? All the data nodes will just keep on looking for name node to come up and interact with it. with them, but that won't happen. So single point of failover. Similar way, job tracker. If one job tracker fails, what will happen? None of the jobs will get executed, right? So single point of failover applies for the storage as well as for the processing, both of them. Now, another part was if we want to store more and more data. So let's say one single name node can handle around 3000 of data nodes. But what happens if I have more data load? So one name node, it will be very difficult for it to manage more than 3000 of data nodes. So at that particular point of time, again, I'm restricting myself to just 3000 or 3500 data nodes itself, right? Similar to the case with job tracker also. If you want to process more and more jobs, assume that this particular task tracker has got a capability of processing around 1000 jobs. If you have 2000 jobs or 3000 jobs, what will you do? Again, you will have to restrict yourself to 1000, and then after thousands are getting completed, you'll bring upon another 1000. But again, you are not able to parallelly execute 3000 or 4000 jobs. So these were the limitations which were overcome by the yarn and the new kind of architecture which Hadoop 2x brought upon. Okay, so I'll discuss about it in very detail later on. Okay, but I just gave you an idea like what were the limitations in Hadoop 1.x, which were overcome by Hadoop 2.x and Hadoop 3.x. If you see, I have just changed the slide. You can see here, it is Hadoop 3.x. The component remain the same, but there are internal changes. Again, we will discuss about it. Okay, don't worry. So component wise, I believe you have got the familiarity. Now, let me tell you, if you want to configure this Hadoop into your machine, so let me take you to that diagram. Look at this particular diagram. Don't get confused by the complexity of the diagram. I'll explain you each and everything. So here, if you see that the bottommost layer, okay, this particular layer, think it like your laptop or a CPU. The bottommost layer is of hardware, and the hardware today we have all the hardware are virtualization technology enabled. And if you don't have virtualization technology enabled, that is fine. You can directly install Cent operating system or Ubuntu or Red Hat. So we actually require some sort of operating system. Even if you don't have any kind of Linux operating system or you are very much familiar with Windows, we are completely okay with that. You can make a setup on top of that also. But if you really have around 8 GB or 16 GB or 32 GB of RAM into your laptop, then basically I would suggest why not to enable the virtualization technology. And if you have Windows operating system, then on top of it, install a virtualization software. For example, VMware Workstation is there, Oracle VirtualBox is there, KVM is there. So many softwares are there which help you to virtualize your hardware, right? So install a virtualization software, and after that, using that VMware Workstation or Oracle VirtualBox, you can install multiple operating systems on top of your single operating system. This will enable you to create more than one instances, and in a distributed manner you can create the Hadoop environment. That will give you a real sense of that how, and even in production environment, how the configurations are done, or in a distributed fashion how the configurations are done. So these understandings you will get. Okay, so this is my recommendation. If you have a good RAM capacity, if you have virtualization enabled hardware, then go for it. Fine. What we will do exactly, let me tell you. So we will have a Linux. So I am basically fan of CentOS. It's an open source operating system, free licensing, general public license you will get for CentOS. So go for CentOS 6, 7, or 8. Okay, you can go for any release of CentOS. Hadoop is compatible with all of them. Then on top of CentOS, you install your SDFS layer, you install your MapReduce layer. You can see that this is the CentOS layer, the OS layer, where the OS level like file system is there and other components or processes are running. Then on top of it, install SDFS. So I told you what is SDFS: name node, secondary name node, and data node. So these three come together, they make SDFS part, right? And then on top of it, we have a MapReduce layer. So we have resource manager and node manager, or you can see this is a yarn layer. Yarn MapReduce I have written because the processing in Hadoop, in the native processing that has been MapReduce. That's why I have written MapReduce here. But you can run Spark, you can run other graph applications as well on top of Hadoop with the help of yarn architecture. Okay, now you have some client tools here. Scoop is there, Flume is there, Linux shell is there, which is getting connected to Hadoop for storage purpose or for running some job. So this kind of architecture you can have in your own machine. And don't worry, I will be teaching you that as well. I'll be creating tutorials that how you can set up all this into your own machines. Okay, so be happy about it. Let's move ahead and discuss it further. So what all sorts of installations can you have? I'll demonstrate all of them. This is the first kind of installation you can have. We call it as pseudo node cluster. Pseudo means false actually, okay, because it's not a cluster. It's just a single machine. So in a single machine, we install everything: name node, data node, secondary name node, node manager, resource manager, everything we install in a single machine. It doesn't remain a cluster at all, right? But this is okay for practice purpose. If you are practicing configuring Hadoop, you can start with single node where all the components of Hadoop, name node, secondary name node, data node, and node manager and resource manager, all the masters and all the slaves are sitting together into one machine. And after that, what we can do is, after that we can have one more machine added where we can have data node and node manager. Understand, this machine is having master as well as slaves, but the second machine, if you see, it is having only slaves. So whatever n number of machines you will be having, all those machines will be having only slaves and slaves and slaves, right? And slave machines will be having data node and node manager together. Remember this thing: slave machine will be having data node and node manager together, because data node will store the data and node manager will process the data. So we need storage as well as we need processing. So therefore, slave machines will have all those. Okay. So this single machine is called as pseudo node. This pseudo node is scalable. I'm sorry, this pseudo node is scalable. Scalable means you can add more number of machines. You can add 10 machines also. It will be working perfectly fine. Okay, so it is scalable. Now let me take you to the second example. Second example is partially distributed. In case of partially distributed, you will have your masters as well as certain slaves. Okay, you can see here you have a master, you have another master, name node, secondary name node, and resource manager. But the master machine is also having both the slave services, both the slave services. Okay, so this is partially distributed, not fully, not completely distributed. This is partially distributed, and this is also good for lab clusters. If you're working into industry, you want to set up a small cluster, you have 4 or 5 machines, you can go ahead with partially distributed cluster, right? So 3 or more machines you have, you set up this. Even you can have, we will see something which is called as replicas. If you have one file, you want to create 2 more replicas of it, so total 3 replicas would be there. So if you have 3 machines, one replica will be in this data node, another replica will be in this data node, another replica will be in this data node. So even with 3 you can go ahead, and this is also scalable. This is partially distributed. What is the purpose? The purpose is you can have a lab cluster where your team can practice and access, and it can handle few GBs of data. Okay. Yeah, even it depends on what terabyte of hard disk you have and how much RAM do you have, but it can handle a good amount of data for experimentation purpose. Now let me take you to the fully distributed environment. This is fully distributed environment. Understand, this is just an example. I will tell you in some later, admin videos where I will tell you that how exactly the fully distributed production environment is created. But this is just for the basic understanding. So in fully distributed environment, we have CPUs which are having master services or master components. You can see one name node is in one CPU, secondary name node is another CPU, and resource manager is another CPU. We actually need to keep them separately. Why we need to keep them separately? Because they are very crucial, very important. If name node fails, the whole memory of the cluster is lost. It is like that. So therefore we try to keep them, not we try, we keep them on separate CPUs. Okay. And you can see the slaves are like that only. Slaves, data node and node manager, they are on separate CPUs. They're like that only, right? So we can have n number of CPUs where data node and node manager are installed, and they act as a slave for storing as well as processing purpose. This is fully distributed architecture. All right. I hope you enjoyed this. Do like, subscribe, and share. Thank you. Thanks a lot.